Okay, as we move on to 12.7, we're going to talk about theoretical and experimental probability. And we are going to do the opener here. On one game show, you get one chance to spin the wheel at the right. If the spinner stops on a red section, you win a prize of your choice. On another game show, you choose one of 15 envelopes. 3 of the envelopes contain a prize that you choose. Which game show would you rather be on? Explain your reasoning. Now, I know it would be really helpful if you could see on here which one of these is red, but you can't. So let me tell you that the red ones are here. Let's make it real nice and dark. There's a red one. I like that I'm coloring it in blue, but that would be a red one. And the other red one is here. Okay, now maybe we can approach this problem a little bit better. So when we spin the spinner, we got to count how many things that we have. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So with the spinner, we have 2 reds out of 12. And with the envelopes, they told us that it was a 3 envelopes. It was a 3 out of 15 chance. Now, what I would do, and I'm kind of hoping what you would do as well, is say, well, what's better? 2 out of 12 or 3 out of 15? Well, here's 2 out of 12. I do 2 divided by 12. So like a 17-ish%. And let's do the 3 out of 15. A 20%. So which would you rather do? I hope that you'd rather be on this game show because you have a 20% chance of getting a prize that you would like. Let's move on. In the solve it, the thing we just did, spinning red and choosing the right envelope are desired outcomes. An outcome, that's your blank. An outcome is the result of a single trial, such as spinning the wheel. The sample space is all the possible outcomes. An event is any outcome or group of outcomes. The outcomes that match a given event are what we call favorable outcomes. They're like what we're looking for to happen. You might want to write that down. Here's how these terms apply in rolling an even number on a cube. The event would be rolling an even number. The sample space on a cube is 1, 2, 3, 4, 5, and 6. See if I have it in here. There we go. 1, 2, 3, 4, 5, and 6. This is what they're talking about. The favorable outcomes would be the 2, the 4, and the 6. Now here's an essential understanding for this lesson. The probability of an event, or P parenthesis event, that's what that means, is how you would say that, tells you how likely it is that the event might occur or will occur. You can find probabilities by reasoning mathematically or by using data collected from an experiment. So there's 2 different ways, by reasoning mathematically or by using data that you've collected. So 2 different ways. In the number cube example above, the outcomes in the sample space are equally likely to occur. Like you could get a 1 or a 5 in the exact same, that's likelihood the same. When all the possible outcomes are equally likely, so this is what we're going to underline, equally likely, you can find what we call theoretical probability. It's like, what will probably happen of an event using the following formula. Here we go. This, your big blank here, is theoretical probability. And theoretical probability is, you take the probability of whatever event you're looking at, you put favorable over possible, and now here's an example. Probability of rolling an even, 3 out of 6, which is 1/2. Now you can write the probability of an event as a fraction, a decimal, or a percent. The probability of an event ranges from 0 to 1. For example, this one would be a 0.5 or what we call a 50%. So you see how it's a 0.5? It would be equally likely to occur or equally likely not to occur. Let's try a couple of these problems. Problem number 1. Our solar system's 8 planets in order of least to greatest distance from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. No more Pluto. You will randomly draw one of the names of the planets, and you're going to write a report of that planet. What is the theoretical probability that you will select a planet whose distance from the Sun is less than Earth? So we're going to write this all together. The probability of getting a planet whose distance is less than Earth's would be, well, first of all, how many are there total? There's 8 total, right? So how many are closer to the Sun? Mercury and Venus. So we put 2. We rearrange that to 1/4. That's the probability. As a decimal, that's a 0.25. As a percent, it's 25%. So there's a 1 in 4 shot that you're going to pick somebody whose distance is to the Sun is smaller than Earth's distance to the Sun. Can we do the got it? We're going to do the same thing. It says our solar system's 8 planets, yada yada yada. Now, what is the theoretical probability that you're going to select a planet whose distance from the Sun is greater than Earth? So probability of getting the planet whose distance away from the Sun is greater than Earth. Well, here's Earth. So that would be Mars, Jupiter, Saturn, Uranus, and Neptune. So how many is that? 1, 2, 3, 4, 5 out of 8. That does not reduce. That is your fraction. Now we can get it as a decimal if we wanted to. 0.625. So it's a little more likely to occur because it's closer to 1. Maybe you should write that down. I'll say it again. It's a little more likely to occur because it's closer to 1. As a percent, it would be 62.5%. So you have a 5 out of 8 shot of picking a planet whose distance to the Sun is greater than Earth's. Next, we are going to talk about a complement of an event. When you get to geometry, you're going to talk about something called a complement of an angle. And you're going to learn that 2 things complement each other if they make 90. Well, in algebra and statistics, a complement of event is everything that you're missing, pretty much. Like, that's the fire alarm. Okay, if you hear that, the fire alarm is going off, but don't worry, I'm safe. They're just testing the elevator. Okay, so the complement of an event consists of all outcomes in the sample space that are not in the event. The possible outcomes for rolling a number, the possible outcomes for rolling a number on a cube, here it is, are 1, 2, 3, 4, 5, and 6. The outcomes for rolling an even are 2, 4, 6. Now look at the complement. The complement is not the evens. Okay, so the complement would be 1, 3, and 5. Now together, that's what I mean by the sum, together the event and its complement make 1. Problem number 2. Consumer research. In a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of, the fire alarm's off. There are 20 samples of drink A. There are 10 samples of drink B. And there are 10 samples of drink C. And 10 samples of drink D. What is the probability of a participant not getting drink A? All right, well, let's go ahead and look at the complement of the complement of an event. So what we're going to do is we want to figure out the probability of not getting drink A. So, since we know that the probability of getting A would be a 20 out of 50, the probability of not getting A is the subtraction. It's a 30 out of 50 chance. So that would be a 3 out of 5. So if getting A is 20 out of 50, and maybe you're wondering where I got 50 from, it's because there's 20 of A, 10 of B, 10 of C, and 10 of D. Add them up, you get 50. So if we know that A is 20 out of 50, we know its complement is 30 out of 50. So 3 over 5. In the got it, we have the same drink test, and it says, suppose that the taste test is repeated with the same number of samples of drink A, but more samples of other drinks. What happens to the probability of not getting A? Well, if the other ones increase, that tells us that the probability of not A also increases. All right, we'll finish this lesson up on one more video.